There are three main ways that we can identify similar triangles. The first is the angle-angle similarity postulate that says that if two angles of one triangle are congruent to two angles of another, then the triangles are similar. So I'll draw a small triangle and a larger triangle. And what this postulate is saying is that if that angle is equal to this angle, and that angle is equal to that one, then the triangles are similar. We just need two pairs to match up, two pairs of the angles to match up. Another way that we can identify similar triangles is through the side-side-side similarity theorem. It says that if the measures of corresponding sides of two triangles are proportional, so if we have a true proportion, then the triangles are similar. So we'll draw another small triangle, a larger one. So we're going to line up the ratios. Smallest side to smallest side, middle to middle, and largest over largest. And what we want to check is if all three of these fractions reduce to the same decimal. And they do. This is 0.3 repeating, this is 0.3 repeating, and this is 0.3 repeating. So yes, they are proportional, which means that the two triangles are similar. The last way is the side-angle-side similarity theorem. It says if the measures of two sides of a triangle are proportional to the measures of two corresponding sides of another triangle, and the included angle or angles are congruent, then the triangles are similar. So let's draw these triangles out real quickly. So we can see that the sides are in proportion. We have 5 to 10 and 7 to 14. So essentially the scale factor or the ratio is 1 to 2. Then we need the included angle. So if those are, if our setup looks like this, then we are in good shape. We should write out our proportion. We want to make sure that we write out that 5 over 10 equals 7 over 14, and that we checked because that's 0.5 and that's 0.5. In right triangles, there is a special case, and it says that if the altitude, I'll actually go down here so we're a little bit better. If the altitude of the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original, then they're similar to each other. So if we have the altitude to the hypotenuse, then we are dividing the triangle into two similar triangles because all three of them are right triangles. So triangle ABC is the largest triangle. It's this one right here. And then we have two smaller triangles. One of the smaller triangles is ACD. We want to be careful about how we label that. C was the right angle of the large triangle. We want to make sure that we put D, because it's the right angle, last. And then A was the base angle, one of the base angles, so we can line that up again. And then the second triangle we have is CBD. And again, we want to make sure that we are careful about our ordering so that the congruent angles are noted. Let me know if you have any questions.